In our next section, we're going to look under the Tenants tab of the AP Controller and ACI and talk about how we specifically apply a policy onto the access interfaces that we previously defined under the Fabric policies, and then figure out how we can actually forward traffic through the ACI. Okay, first and foremost, just like we talked about within the case of the Fabric access policies, to understand what's going on inside the tenants, the big thing in the learning curve is going to be to figure out how the policies are tied together under the tenants. So as I mentioned before, a tenant, you can think of this as analogous to a sub-organization within the scope of UCS. It's basically just a container for objects. It doesn't necessarily mean that one tenant cannot talk to another. You can configure the system to leak traffic between the multiple tenants, but with the default behavior, they wouldn't be able to because they're in separate routing tables. Now, within the tenant, we're going to have multiple different objects that we need to talk about and figure out how they fit together. So the tenant is going to contain a VRF. VRF is going to be the same as it is in regular NXOS, regular iOS. It's basically a separate instance of the routing table. So we went to the CLI of the leaf switches and the spine switches. We looked at the infrastructure VRF, which was essentially the ISIS process running behind the scenes in order to establish reachability between the loopbacks, which were the VXLAN tunnel endpoints. Now, inside of the VRFs, we then have the bridge domain. Bridge domain, they really like to stay away from the terminology VLAN, but at the end of the day, that's effectively what it means. It's the broadcast domain. So inside the bridge domain, you can have one or more subnets. Inside the VRF, you can have one or more bridge domains. The bridge domain is going to be called from the endpoint group. The endpoint group is part of an application profile, which is calling a contract, which is calling a subject, which is calling a filter. Okay, the ultimate end goal is that we're going to group our applications together based on their endpoint groups. So we would have an endpoint group that says this is the web server, another endpoint group that says this is the database, a third one that says this is the public internet. Then we would want to define a flow that says when traffic comes from the internet is allowed to talk to the web server, and the web server is allowed to talk to the database. Specifically, the internet is allowed to come in and talk to the web server at TCP port 80. They're also allowed to talk at port 443. And then the web server is allowed to call the database at the SQL port. Okay, this then means that the filter and the subject of the filter would be the actual port numbers, okay, like TCP 80 and 443. The contract would be the web server saying, I'm going to allow the internet to talk to me at port 80 and 443. The endpoint group would be www, which is part of an application profile. Application profile is just going to be another container. Okay, but the endpoint group is then going to be inside of a bridge domain, which is calling a subnet. Subnet would be where the web server's IP address actually lives, and then where the default gateway of the web server would be. Now, we'll see one of the big advantages of the way that the subnet is implemented in ACI is that it's automatically doing anycast for the default gateway of the end hosts. Okay, this is going to be very similar to what we had configured in BGP EVPN and the Fabric forwarding mode anycast gateway, where essentially the default gateway of the end host is going to live on any leaf that we deploy the endpoint group on. So it's not actually programmed into hardware. Basically, the SVI is not programmed into hardware until we deploy the endpoint group in the domain, which is called from the attachable access entity profile, which is calling the switch profile calling the interface profile, calling the interface selector, which ultimately means that port on that particular leaf. So again, a lot of this is going to boil down to understanding how the objects fit together, because what the objects are doing behind the scenes really not that complicated. It's the same type of stuff that we've been doing in networking for 20 plus years, is to say that we have a subnet. Inside of the subnet, we have a default gateway. The subnet belongs to some bridge domain. Okay, the bridge domains are grouped together into a routing table. And then the routing table, we have connections to external networks. Okay, so we have like a default route out to the internet. Okay, but again, what is going to make this really complicated is that if you miss one of the objects, how it's tied together, it's going to be difficult to figure out where that missing piece of the puzzle specifically is. because the ACI is not going to throw a fault at you for every possible misconfig that you do. It's only going to do it for things that are hardware related, like if the temperature is too hot, or anything that is an invalid configuration. Like we tried to create two switch profiles that are named the same object name. So it's not gonna 100% tell you like, hey, you forgot to call the endpoint group from the domain, okay, or you forgot to attach the AAP to the domain, or attach it to the policy group.